While a capitalisation valuation is very simple in itself, there is also a very common adjustment that needs to be done in the case where a property has an existing lease which is out of line with the general market rents. This often happens when a lease is written in such a way that the rent review doesn't keep the rent at the market level, and so there can be a gap that grows over time. Often the property market will move ahead faster than the lease is able to increase the rents, and so you end up with what's known as a profit rent situation to the tenant, and this is where the tenant is paying less in passing rent, in the actual rent according to the lease, than the market rent is, and so it's as though they're making a profit out of holding the lease, and that's a profit taken against the landlord. How do we calculate the value of the property when we have the passing rent that we can capitalise? However, it's under the market, but we also have the market rent available, but it's not what the landlord is able to earn initially, and we do that by a calculation known as a reversion correction. The idea is that at some point in the future the rent will revert back to the market, and at that point the capitalised value of the property will come up to its full value, but because we have to wait for it, we have to do a correction to allow for the time delay. That calculation is very common. You'll find examples of it in the textbook, and here I thought I'd show you how to do it on an Excel spreadsheet so you can build yourself a nice little model that you'll be able to use in either checking the textbook's calculations or doing your own valuations. The other thing which is important as you're working through this is that while we're building this model on an Excel spreadsheet, check the calculations with a financial calculator. In fact, this one can be checked with any reasonable calculator at all, and we'll show you the maths involved as we go along. Okay, in the situation we have here, we have a tenant who is paying a rent of $500,000 a year. So that's known as the passing rent. That's the rent according to the lease. However, the actual market rent is more like $580,000 a year, and that is likely to happen once the lease is renewed, and that's going to happen in 18 months. So it depends on how long the lease has still to go before it expires, and so we look at the lease term remaining, and that's very important because that'll give us the time that we're going to use for an adjustment as we do our calculations. We're going to adopt a capitalisation rate of 8%. We're also going to adopt a discount rate, which we're going to use for the time adjustment. Here I'm using two different rates. Often valuers will adopt a single rate as long as they're shrewdly selected. A single rate for both capitalisation and discount won't introduce so much of a significant error in the final valuation, especially since the reversion is only a minor part of the whole value. Okay, what are we going to do here? First of all, we can work out the capitalised value of the property using the passing rent quite easily. We've done that many times before. That's simply equal to the passing rent divided by the cap rate, and so that gives us $6.25 million. We can also work out what the rent increase is going to be. That's easy. Again, it's simply a subtraction. 580 minus 500 in this example, so that's $80,000. You'll see the yellow highlights have cleared for these two cells, but because of the mechanics of the self-correcting system, it's introduced a couple of extra yellow highlights which we'll take out as we go along. Okay, let's look at the value increase of the reversion. Now what that is simply capitalising this future rent increase. That's quite easy. What it says is that if we have $80,000 and we capitalise that at 8%, that's worth $1 million to us. However, the problem with this $1 million is that while it's going to add to the capitalised value of the passing rent, we have to wait for it to happen. And so we have to adjust that $1 million that we have to wait 18 months to get by the time value of money, which is accounted for by the discount rate. And that gives us the present value of the $1 million. We calculate that by taking the future value. We're going to divide it by 1 plus the discount rate. That's 1 plus the discount rate, close brackets, raised to the power, which is going to be the delay, the number of months. Because we're working in months, not years, we're going to take the 18 months, we're going to divide it by 12. So the equation looks a little bit cumbersome, but really all we're doing is dividing the $1 million, C74, by 1 plus the discount rate, all raised to the time that we have to wait, expressed in years. So that gives us a present value equivalent of $866,000. So it means that the $1 million we have to wait 18 months for is only really worth $866,000 today, and so the total value of the property is the $6.25 million plus the $866,000, and that gives us a value including reversion of $7.1 million. So that's a fairly simple little calculation. The present value calculation here is the only tricky part. I'll show you a different way of calculating that, which uses the Excel built-in functions. You can use either the algebra that we used first up, or we can use the present value function. Present value function asks for the rate, which is going to be 10%. It's going to ask for the number of periods, which is going to be 18 months divided by 12. It's going to ask for the regular payment. Now in this case there's no regular payment. We could put a 0 here, or simply put another comma. And the last thing it's going to ask for is the future value. We put that in as negative, and the future value is $1 million. So the future in the future, 18 months in the future, we're going to receive $1 million, and we're working out the present value of that. That's the Excel equation, and if this is all configured correctly, that will give us the same number. And my computer has a strange habit of putting pound signs in when I want dollar signs, but you can see the numbers are the same, so basically we've got a check there. I'll just change that. Okay, so that's two different ways of doing that critical calculation. You see they return the same value. And that's all there is to reversion. Very simple little calculation, but very, very useful to practice that a couple of times, especially with your financial calculator, so it becomes a little bit second nature, so you understand the logic of it. The logic of it is probably more important than the number, because you're going to be using these kind of calculations a lot in the future.